Happy learning! Today we're going to talk about linear inequalities in two variables. Okay, our goal for today is to really talk about a system of linear inequalities. But before we get to that, we should start with just graphing a single linear inequality in two variables. So let's take a look at maybe the most basic example, y is less than x. So we want to basically graph this inequality. And so what we're going to do, let's draw out our xy plane. We're going to graph the line y equals x. And since we have a strict inequality, we're going to graph it as a dashed line. All right, so this line that I just drew here is the line y equals x. This inequality is either going to be above it or below it. And the way we could check is we take some point off the line. So I'm going to take this point 1, 0. This is going to be called a test point. And we're going to check, does the point 1, 0 satisfy this inequality? Is it true? So here y would be 0. Is it true that 0 is less than 1? Yes. And so we're going to shade the entire half of the plane that's on the same side as this point. Okay? So this shaded region here is the region y is less than x. It's really as simple as this. All right, so let's take a look at an example. Graph the inequality for x minus 2y is less than or equal to 6. All right, so try this on your own. Use the same techniques as before, and then pause the video, try it on your own, and then come back. So welcome back. I hope you enjoyed trying the problem. So the first thing we have to do is we want to graph the line 4x minus 2y equals 6. All right, what does this look like? Let's solve for y. And then it'll be easier to graph. So subtract over the 4x. So minus 2y is equal to minus 4x plus 6. And then we'll divide by 2. So y is equal to 2x minus 3. Our original inequality has the equal sign. So we're going to draw a solid line. We're going to draw literally this line. So let's go down 3. Right, this is the line y equals 2x minus 3. And now we need to determine, do we shade above the line or below the line? So I'm going to use the origin 0, 0 as our test point. Is it true that 4 times 0 minus 2 times 0? So is 4 times 0 minus 2 times 0, is that less than or equal to 6? Yes. So we're going to shade in the direction of the test point, which is up here this time. If I picked a point down here, this inequality would not be satisfied. So I would shade away from it. So that's how you graph a single inequality. So if we have two or more inequalities, we could find the solutions that satisfy all the inequalities. We call this a system of inequalities. Kind of like a system of equations was the set of points that satisfied a bunch of equations. A system of inequalities is the set of points that satisfy a bunch of inequalities. And the solution of the system can be found by finding the intersection of the solution sets of all the inequalities. All right, so we're going to find a bunch of these shaded regions, and we want to find the points that are shaded every single time. If they're only shaded once, then we're not going to include it. It needs to be shaded every single time. All right, let's take a look at an example. Graph the solution of the system 3x minus 2y is greater than or equal to 4, and x plus y minus 3 is strictly greater than 0. All right, so we're going to find the region that satisfies this inequality, find the region that satisfies this inequality, and look for the overlap. I think you could do this. All right, so let's pause the video, try it on your own. Let me know in the comments if you were able to get it. Boy, that would make my day if somebody left a comment saying they were able to get it, even if it was a lie. Okay, so let's do this. Let's do this now. So we're going to start by graphing the lines. So I'm going to take this first line. We're going to graph it solid because it's the weak inequality and it contains the equal sign. The second one will be dashed. All right, so 3x minus 2y equals 4. Solving for y, this gives us y equals 3 halves x minus 2. That's going to be a solid line. The other line, which will be dashed, is x plus y minus 3 equals 0. Solving for y, we get y equals negative x plus 3. Okay, let's sketch these two lines. Our y-intercept is 0, negative 2. And our slope is 3 halves, so we're going to go up 3 over 2. And it's solid. Right? Why is it solid? Because we have the equal to here. Now let's graph this line. This will be dashed. All right, now we have to determine which region do we shade. And so let's take the test point again. Let's take the origin to be the test point. So dealing with our solid line, is it true that 0 minus 0 is greater than or equal to 4? No. So we're going to shade away from the origin. And same test point. Is it true that 0 plus 0 minus 3 is greater than 0? The answer is still no. So we're going to be shading away from the origin for the dashed line as well. What region is shaded both times? It's this region here. All right, so our solution is this region. The last thing we need to do is we need to figure out where do these two lines intersect. Okay, and how do we do that? We solve the system of equations. We have y as a function of x here. We have y here. We could set these equal to each other, and that will give us our x value, and then we'll get the y value. All right, so this is negative x plus 3 equals 3 halves x minus 2. Subtracting this over, this is negative 5 halves x equals negative 5, or x equals 2. And then subbing that into either of these equations, we get y equals 1. All right, so we need to label these corners. They're going to play a big role when we look at some applications. So this is the point 2, 1. All right, so our region, I'm going to clean this up a little bit. This set of points with this corner is the region to that system. It's the solution to the system. OK, let's look at another example. It's possible that we have more than 2 inequalities. We could really have as many as we want. So let's graph the solution to the system. All right, and so we're going to have 4 inequalities here. The first one is x plus 2y is less than or equal to 10. 2x plus y is less than or equal to 14. X is greater than or equal to 0. And y is greater than or equal to 0. All right, so just like we did in the last example, let's just graph the lines when these are equalities. And then we'll take a test point. So this becomes y equals minus 1/2 x plus 5. This is y equals minus 2x plus 14. And then x is greater than or equal to 0. Y is greater than or equal to 0. That's saying our region is in the first quadrant. All right, so we really don't have to worry about these too much. We just know our answer is going to be our region is in the first quadrant. So let's just draw only the first quadrant. OK, and so what does this look like? We have a y-intercept of 5. So let's say this is 5, 10, and then up here is 15. And a slope of negative 1/2. Here we have a y-intercept of 14 and a slope of negative 2. OK, a little bit of a wobbly line, but it gets the point across. And now what region do we shade? Are we going to shade this region, this region, this region, or this region? Again, let's take the origin. Is it true that 0 plus 0 is less than or equal to 10? Yes. So we're going to be shading towards the origin here. And is it true that 0 plus 0 is less than or equal to 14? Yes. So we're going to be shading towards the origin here. What region was shaded twice? Well, it was this region here. Okay, the last thing we need, though, is we need the corners. This corner is easy. It's the origin. This corner is also easy. It's the y-intercept of this line here. This corner, not that easy. This corner, simple enough. It's when this line intersects the x-axis. So this corner here is when minus 2x plus 14 equals 0. That's when x equals 7. Okay, so this corner is 7, 0. And now we're stuck with this last corner. And so how do we get that? That is when these two lines intersect. So we could set them equal to each other, just like we did in the last example. So minus 1/2 x plus 5 equals minus 2x plus 14. Let's add the 2x over. That's 3/2 x. And subtract over the 5 equals 9. And now getting x by itself, we get x equals 6. All right, so the x component of this point is 6. And to get the y component, we sub it into either one of these equations. So subbing it into here, we get negative 12 plus 14, 2. All right, so we have, this is our region. I'm going to kind of erase everything else. This region here, this quadrilateral, is the solution set. Okay, I know that was a little bit quick today, but I hope you found this useful, and we'll take a look at some applications in the next video. All right, bye-bye.